This is Victor from Florida, and today we're going to be talking about routing. What is the whole process of taking communication from your network to another network over there on your field? So basically, we got a lot of dots coming over. This is kind of funny. Anyway, we just want to talk about routing, how everything is coming, how the communication works, what is the whole process that's gonna be involved in that kind of stuff. So I hope that you enjoy it and you have a lot of fun with it. Thank you very much for watching. Please come with me and let's double check that information. Bye, guys.
Hello everybody, we're going to be talking today about routing. How to route a packet from one network to another. Basically, we are going to try to remember how the fields in the IP header are used to route a packet from one network to another. For example, you're in the IT department and you are requesting a file that is located in the data center or maybe in the content department that is in a complete different network. How can you get over there? How the packets are routing from one place to another? The solution for that is going to be routing. That's how can we route a packet from PC1 to the server, as you could see over here in the graphic. In the IP header that we were talking previously, we have the source IP address, the source MAC address, and we are going to try to get that information to the other network over here, to the servers, that is the destination IP address and the destination MAC address. After we got that information, basically we are going to start trying to look for some information. So the main thing that we see over here is that we have two different networks, guys. One is with the IP address 192.168.1.0 network, different IP address, and the other one is over here with the network 192.168.5.0 network. That is interesting. And this is slash 24 over here, and the routers are handling an slash 30 IP address. Interesting, isn't it? So, as you could see, we have two different IP addresses coming from two different places. So, what does PC1 does? PC1 compares its IP address with the server's IP address, and PC1 concludes that the destination IP address resides on a remote subnet. So, PC1 will send a packet through its default gateway, and the default gateway is learned dynamically through the HTTP dynamic host protocol, or we are gonna be assigning that directly through, well, manually we're gonna reconfigure that. So remember that we can do that through the network section of our computer. So PC1 is the MAC address of the default gateway. So PC1 will send an address resolution protocol request to R1 MAC address. So after PC1 receives an ARP reply from router's PC1, PC1 adds the R1 MAC address to its ARP cache. Look, so as we mentioned before, it's going to be something similar to this. It's going to send an ARP request. After you get the ARP request from the PC1 directly to R1 router 1, the R1 is going to reply with ARP reply. Assuming that the time to leave is not a decrement to 0, router 1 check its routing table to determine the best path to reach network 192.168.5.0. So it's gonna send we're gonna send a data frame to that network that is accessible through interface serial 1.1, the one that you're gonna be looking over here. R1 therefore forward the frame out of the serial 1/1 interface, as you could see over here. R1 checks the routing table to find out the best path to get to 192.168.5.0/24 network, that you could see over here in this graphic. And I want to find out that 192.168.5.0 is accessible through the interface S1/1, as we mentioned before. So it gets the data frame. When router 2 receives the data frame, it decrements the time to live in the IP header, just as router 1 did. Again, assuming that time to live did not get the decrement to 0, router 2 interrogates the IP header to determine the destination network. The destination network, as you remember, is 192.168.5.0 that we mentioned previously. So, after R2 interrogated to find out the destination network, the destination is attached to the F0/0 interface. This one over here, guys. So, after that, R2 send an ARP request to determine the MAC address of the server, guys. The one that you see over here, 6666, whatever. So, guys, basically, you can see that router 1 sends an IP request to determine the MAC address to server 1, and we get the communication going. After that, router 2 send the frame out of a fast Ethernet 0/0 interface to the server, as we illustrate, and that frame got the original, the source IP address, the source MAC address, the source, the destination IP address, and the destination MAC address. Guys, I hope that information was useful for you. In case that you have any question, please be free to ask. My name is Victor from Florida, and over here to help you with the routing information. How does that work? I hope that this graphic was helpful for you. Have an excellent day. I will keep in touch. Bye, guys.